Okay, in this tutorial, I'm talking to you about inferential statistics, specifically 2022 Paper 2, Question 5. We're told that a survey of 400 students took place, and the number of the students that said that they preferred remote learning to face-to-face learning is 135. So we're asked to work out the proportion of students that preferred remote learning. So obviously it's just 135 over the total number of students in the survey, and to 4 decimal places it's 0.3375. In part 2, we're asked to come up with a 95% confidence interval for the proportion of people that prefer remote learning. And instead of using the normal margin of error, we're asked to use 1 over the square root of n. Remember, this is just a rough estimate. It's not as accurate as the other margins of error that we've gone through on the course. To come up with a confidence interval, it's always the result of your sample plus or minus the margin of error. In other words, in this case, it's p hat, the proportion of my sample that preferred remote learning, plus or minus the margin of error 1 over the square root of n. We worked out p hat previously, it's 0.3375, and 1 over the square root of n is 1 over the square root of 400, which ultimately works out as 0.05. So to come up with your confidence interval, p, the proportion of the entire population that actually prefer remote learning, must lie, there's a 95% chance it lies within this range, between p hat minus the margin of error and p hat plus the margin of error. In part 3, we're repeating part 2, except we're doing it accurately. Instead of using the margin of error as 1 over the square root of n, we use the margin of error that we know to be more accurate. Usually what we do, the margin of error is 1.96 times the standard error. And you get the standard error from the proportion from your maths tables. It's the square root of p times 1 minus p over n. However, remember that in this case we don't know what p is. Hence, that's what we're trying to come up with an estimate for what p might be. So even though this is the standard error that you get in your maths tables, instead of using p, we are going to use p hat. Because p hat, the sample proportion, is our best estimate for what p, the population proportion, might actually be. So we use the square root of p hat times 1 minus p hat over n, and if you multiply that by 1.96, that gives you the margin of error for this confidence interval. P hat is 0.3375, then it's plus or minus, you just sub in your p hat and you sub in your n. Then the margin of error, if you plug that into your calculator, works out as 0.04634. So to come up with an accurate estimate for what p is, it's p hat plus the margin of error and p hat minus the margin of error. We're 95% sure that the proportion of students that actually prefer remote learning lies within this range. And this is more accurate than the one we did in part 2. Okay, in part B, we're told that in 2019, the average amount that people spent per month on their prepay phones was €20.79. That is a mu, that is a population mean. It's implied that that's the average of everyone, the average of all the people with prepay mobile phones, that's their average monthly bill. So now 2 years later, we take a sample of 500 people. And the average monthly spend of these 500 people is €22.16, and the standard deviation is €8.12. So if you glance at that, it would appear that the average from 2021 has risen from 2019. However, there's a chance that the 500 people we surveyed just happened to be on fancy mobile phone plans. It might be just a coincidence that these 500 people happen to spend more than the average person in the population. So we need to carry out a statistical analysis to figure out, could it be a coincidence that x bar is bigger than mu, or is x bar so much bigger than mu that it couldn't possibly be a coincidence that in fact the average of the population has changed? So you have to first of all state your null hypothesis and then state your alternative hypothesis. The null hypothesis is always that nothing has changed. So if the average in 2019 of the population was €20.79, our null hypothesis is that in 2021, the mean monthly plan is still €20.79, that it hasn't actually changed. The alternative hypothesis is that it is not €20.79, that it has in fact changed. So the calculations are quite straightforward. You simply go to your maths tables and you take down your one sample z test. To work out z, it's just x bar minus mu all divided by sigma over the square root of n. That's all given in the question. When you plug it into your calculator, you get 3.77. Remember, the only thing we care about is whether this number is bigger than 1.96 or smaller than minus 1.96. So this is a really, really big z-score, which indicates that we are going to reject HO. Okay, so now we have to make our conclusion. The conclusion is we're going to reject HO. All the rest of what I've written here is what you should have for your reason. I always tell students, you should now sketch yourself a normal curve. Just sketch a normal distribution, mark in 1.96 and mark in minus 1.96. Indicate that if your z-score had been within that region, you would have failed to reject HO. Indicate that if your z-score is outside, if it's lower than this number or bigger than this number, in that scenario, you would reject HO. And then clearly our z-score is labelled here. It's way outside our range, so we're definitely going to reject HO. You can go further and you can use it as, say, an inequality. Our z-score is greater than 1.96, therefore we're rejecting HO. If you're rejecting HO, that means you should then just write your HA. If we're rejecting HO, we think that HA this is what's actually going on. We think that the mean monthly spend is not 27.79. That in 2021 it has actually changed and it's different from what it was 2 years ago.